Welcome to Electrical Mind. Today topic is about the controlling system. In our last class we saw about the deflection system. So today we will see about the controlling system. Actually this controlling system, it must provide a force so that the current will produce deflection of the pointer proportional to its magnitude is called controlling system. So the important functions of the controlling systems are of two. So first function is it must produce a force equal and opposite to the deflecting force in order to make the deflection pointer at the definite magnitude. So due to the when there is no presence of the controlling system, the pointer will swing beyond its original position of the and deflect, and the deflection will become indefinite. So this is the first function of the controlling system. So next function is it brings the moving system back to the zero position. So due to the presence of the controlling system, if the pointer goes beyond to its position, due to the controlling system it will bring back to the moving system to the zero position. When the force which causes the movement of the moving system is removed, it will never come back to the zero position. So when the moving system is not present it won't go back to the zero position. It will never come back to the zero position in the absence of the controlling system. So for every instrument the controlling system must important. So for this controlling system we have generally two controls. First one is gravity control and next one is spring control. So this is the gravity control figure. So it is the gravity control. It consists of the small weight attached to the moving system. So in between these we have the small weight. This is the control weight, and this in between this is the balance weight. So the weight in between the moving system it can be adjustable. So this weight produces the controlling torque due to the presence of the gravity. This weight will produce the controlling torque. This is called, so this weight is known as the control weight. It produces control torque, so it is called control weight. So at zero position the controlling torque is 0. This we can see in the figure 2. In this the system deflects between the angle theta, so that the controlling torque acts at the distance of L from the center. The component W sin theta of this weight tries to restore the pointer back to the zero position. So this W sin theta restores the pointer to zero position. So so bringing back to the zero position means it is a controlling torque Tc. So that controlling torque Tc is equal to W sin theta into L. This is the controlling torque. Tc is equal to W sin theta into L, where this is equal to K sin theta. K is equal to WL. This is called gravity constant. K is equal to WL is a gravity constant. Next, deflecting torque Td is equal to Kt into I. Td is equal to Kt into I, where this K is another constant. This K is another constant. So later in equilibrium position Td is equal to Tc. The equilibrium position deflecting torque is equal to controlling torque. So where Td deflecting torque is kt into I, Td is equal to kt into I, Tc controlling torque is k sin theta, Tc is equal to k sin theta. So where therefore current is directly proportional to sin theta. Here the key point is, as it is the function of sin theta, so the instrument is using gravity control is not a uniform. It is not the, so in gravity control the function of sin theta, due to the it is a function of the sin theta, the instrument using gravity control, it is not a uniform. So this is about the gravity control mechanism. So now we will see about the spring control mechanism. First one is gravity control mechanism, second one is spring control mechanism. The name itself says in this control we have the springs. So the inner end of the spring is attached to the spindle, while the outer one is attached to a arm. So the inner one is attached to the spindle and the outer one is attached to the arm, which is activated by a set of screw mounted. With the help of screws it is mounted at the front of the instrument. It is directly proportional to the angular deflection of the pointer. So these are the two controlling springs. Inner end is attached to the spindle and the outer one is attached to a arm, which is actuated by the set of screws. So this is the control springs. So what will happen in this control springs means, the instrument at the front of the instrument, it is directly proportional to the angular deflection of the pointer. So it is the uniform scale. This is the pointer, this is the jeweled bearing, this is the balance weight. So this balance weight we see in the gravity control also, where E is known as the Young's modulus of the spring material in Newton per meter square, T is the thickness of the meters, B is the depth in meters, L is the length in meters, Ks means spring constant. So this is equal to, spring constant is equal to EB T cube by 12L. So therefore this controlling torque is directly proportional to the theta. Tc is directly proportional to theta. At equilibrium state, deflecting torque is equal to controlling torque. Same in gravity control also. At equilibrium position, Td is equal to Tc. Td is equal to Tc in equilibrium position. So that at equilibrium position the current is directly proportional to theta. The spring control is uniform. In this spring control is a uniform, whereas in gravity control it is not a uniform. So the deflection is directly proportional to the current. When the current is removed due to the spring force, the pointer comes back to the initial position. So then after, the spring control is very popular and is used in almost all instruments. So this is about the spring control and gravity control in controlling system. In next video we will see about the damping system. ఈ వీడియో గాని మీకు నచ్చినట్లయితే లైక్, షేర్, సబ్స్క్రైబ్ టు మై ఛానల్. థ్యాంక్ యూ సో మచ్ ఫర్ వాచింగ్.